everyone, welcome to this video, and in this video we're going to discuss parallel lines cut by transversal. Let's have some definition of terms here, like parallel lines are coplanar lines that do not intersect, and then a transversal is a line that intersects two or more lines. So technically, let's have now an example. Here's an example. P is parallel to Q and R is a transversal. As you can see, this is how you read P is parallel to Q and R is a transversal. As you can see, this is line P, this is line Q, and this is line R. As you can see, it forms angles. The intersection of R to line P and then the intersection of R to line Q. As you can see, we have A, B, C, D, W, X, Y, Z as the line. Now, there are some relationship and some terms that you could work on with parallel lines cut by a transversal. Now, let's have this one. Once again, the example is parallel. P is parallel to Q and R is a transversal. Now, let's go with corresponding angles. Now, as you can see in the given, A corresponds to W. Another, B corresponds to X, C corresponds to Y, and D corresponds to Z. Now, the relationship of the corresponding angles are equal in measure. So whatever the measure of angle A is the measure of W, B, the measure of B would be the measure of X, the measure of C that would be the measure of Y, and D, the measure of D is the measure of Z. And that is now corresponding angles. Let's have another one. Next is what we call the exterior angles. Now, the exterior angles, such as A and B, and Z and Y, these are both located at the external part of the parallel lines. If we have exterior, we have interior angles. The interior angles are in the internal or between the parallel lines, so such as B and C, and W and X. Both exterior and interior angles in the same on the same parallel line on the same parallel lines are supplementary. Now let's have this one. So we have now same side exterior. Now, so as you can see, these are A and Z, and another one is B and Y. So same side exterior, the relationship is supplementary. We have also same side interior. As you can see, we have now D and W. This is D and this is W. We have C and X. And technically, their relationship is supplementary. Next, another is what we call the alternate interior. We say alternate interior, these are D and X. And we have now C and W. And the relationship are equal. Okay, let's have now alternate exterior angles. So A and Y, B and C. As you can see, A and Y on the location. This is now A. Wait, let me have my pointer. A and Y, and then B and Z. Now, those two are equal in measure. Okay? So, let's have the next slide. The corresponding angles are equal. Same side exterior angles are supplementary. Same side interior angles are supplementary. Alternate exterior angles are equal, and also the alternate interior angles. Now, these are things that when you prove lines to be parallel, or this should be one of their characteristics. So let's have some example on the next slide. Here is our problem. Identify if the given lines are parallel. Let's have now the figure. Now here's the figure. We have there a triangle which is ADB, and then the line there is DP, and there are given measures such as angle A is 55, and then angle D or ADB is 65, and then angle BDP is 60. So you can see 65 and then 60. Now, you're asked now, is AB parallel to DP? That's a question, right? Now, how are you going to work on with that? As you can see, it's quite difficult if you don't know those elements, like what we discussed in the parallel lines cut by transversal. So we're testing if we would extend. Let me just get a pen here. me just get a pen here. And then if you extend this one, this is now our parallel. And this could be our transversal, sorry for that. Okay. Assuming this is 55, so technically here, this should be 55, right? So you could prove that by working on the alternate interior angles. So if you prove that this 55, we could say that AB and DP are parallel. So if you add 65 and 60, that is 125. Then you deduct that because this is a semicircle or half of a circle, that's 180. So 125, you deduct 125 to 180, so you got now 55. So if this is 55, therefore we can conclude that the alternate exterior, this line DP and AB are parallel. So by inspection, you have now the alternate interior. That's not exterior. That should be interior, right? Because we work in an interior, right? So very live on how to record this one. So that is now alternate interior. Make sense? So that's how it works. So we can work that out. Okay, let's go on another problem. I think that will be the last problem on the next slide. Now, what is the value of x and y? So you can see there's the x and y. Let me have now the figure. Here's the figure. So I think we know already the value of x, right? I think the value of x is 55 and the value of y is 60. How does it work? Because 55 plus 65, because the sum of the interior angles of the triangle is 180. I think what's missing is now is 60, right? I hope you learned something with parallel lines cut by transversal, and you can prove now a figure that there are parallel lines. So I hope you learned something with this video. Thank you for watching and have a great